Military engineers said it was impossible. Navy admirals called it suicide. Even Eisenhower had doubts. But one Louisiana boat builder designed a plywood ramp that put 150,000 soldiers on the beaches of Normandy and changed history. It's 1942. America needs to invade Europe. But there's one massive problem nobody can solve. How do you get tanks and troops from ships onto beaches without docks or harbors? Every solution fails. Soldiers are drowning. Equipment is lost. The invasion seems impossible. Then a civilian boat builder from New Orleans walks into a military office with sketches of something that looks absolutely crazy. A flat-bottomed boat with a front that drops down, built from plywood. And somehow, this insane idea becomes the weapon that wins the war. Let's set the scene. It's late 1941, early 1942. America just entered World War II. The strategy is clear. Defeat Germany first. That means invading Europe. But Europe is a fortress. Germany controls the entire coastline from Norway to Spain. Every port is heavily defended. Every harbor has mines, artillery, and troops ready to repel an invasion. You can't just sail into a port and unload. You need to land on beaches. Open beaches where the Germans aren't expecting you. But here's the problem. Beaches don't have docks. They don't have piers. They're just sand and rocks and surf. And the military needs to land thousands of troops and hundreds of vehicles. Tanks, trucks, artillery, jeeps, supplies. All of this heavy equipment needs to get from ships offshore onto the beach. How do you do that? The traditional method is to use small boats. Troops climb down cargo nets from big ships into little boats. The boats motor to shore. The troops jump out into the water and wade to the beach. This works for infantry, kind of. It's dangerous. Men fall from the nets. Boats capsize in rough surf. Soldiers with full gear drown in deep water. But at least it's possible. But vehicles, forget it. You can't load a 30-ton tank into a small boat. Even if you could, how would you get it off the boat onto the beach? The boat isn't strong enough to beach itself on sand. If you try, it gets stuck or damaged. And even if you somehow beach the boat, there's no way to drive a tank off a boat that's bobbing in the surf. The Navy has cargo ships that can carry vehicles. They use cranes to lower them into the water. But this only works in calm, deep water. Near a beach, the water is too shallow for cargo ships. The waves are too rough. And using cranes is incredibly slow. You might manage to offload one vehicle every 30 minutes. An invasion needs hundreds of vehicles in the first hour. The math doesn't work. Some engineers propose building temporary piers. You'd position ships offshore, extend some kind of bridge or ramp from the ship to the beach, and drive vehicles across. But building a pier under fire, in the surf, with the tide changing every 6 hours, is basically impossible. The materials would be enormous. The construction time would be hours or days. The whole invasion force would be sitting ducks for German artillery. Other ideas are equally impractical. Some suggest waiting for low tide and driving vehicles directly off grounded ships. But ships that ground themselves can't get back out to sea. You'd lose your entire fleet. Others propose using floating platforms that vehicles could drive onto, then towing the platforms to shore. But platforms are unstable in surf. They flip. They break apart. Equipment gets dumped into the ocean. The British have been thinking about this problem since 1940, when they realized they'd eventually need to invade France. They've tested various designs. Most fail completely. A few show promise, but have serious limitations. The British have developed a boat called the Motor Landing Craft, or MLC. It's a small steel boat that can carry about 20 tons. It has a ramp at the front that lowers onto the beach. Troops or light vehicles can drive off. It's better than nothing, but it's too small for tanks. And it's made of steel, which is in short supply. Building thousands of them would consume resources needed for warships. By early 1942, the problem is critical. The Allies are planning major amphibious operations. North Africa, Sicily, eventually France. Every operation will require landing thousands of troops and hundreds of vehicles on beaches. Without a reliable way to do this, the invasions will fail. Men will die. The war will be lost. The military holds conferences. They bring in naval architects, marine engineers, ship designers. Everyone agrees on what's needed. A boat that can cross open ocean, carry heavy vehicles, beach itself on sand without getting stuck, have a ramp that lowers so vehicles can drive off, be cheap and fast to build, and most importantly, be mass-produced, not hundreds, thousands. The requirements seem impossible. No such boat exists. No one knows how to build one. Enter Andrew Jackson Higgins. He's 55 years old in 1942. He runs a boat-building company in New Orleans. Higgins Industries. He's not a naval architect with a degree. He's a self-taught designer who's been building boats since he was a kid. He grew up in Nebraska, which doesn't have an ocean, but he fell in love with boats anyway. He moved to Louisiana in the 1920s and started designing boats for the oil industry, for trappers in the bayous, for anyone who needed a shallow draft boat that could navigate rivers and swamps. Higgins has a reputation. He's stubborn, combative. He fights with anyone who tells him something can't be done. He's also brilliant. His boats are innovative. He's developed a design called the Eureka boat. It's flat-bottomed, which means it can operate in very shallow water. It has a unique hull shape that lets it power over sandbars instead of getting stuck. It's made of wood, mostly plywood, which makes it cheap and fast to build. Oil companies and trappers love the Eureka. It's practical, reliable. Tough. In 1941, the Marine Corps is testing landing craft designs. They hear about Higgins and his shallow draft boats. They invite him to submit a design. Higgins shows them the Eureka. The Marines test it. It's good, really good. It can approach a beach, nose right up onto the sand, drop troops off, then back off into deep water, and repeat. The hull doesn't get damaged. It doesn't get stuck. The Marines order some Eurekas for evaluation, but there's a problem. The Eureka has a pointed bow like a normal boat. Troops have to jump off the sides into the water. This exposes them to enemy fire. They're vulnerable. And vehicles can't be carried at all because there's no way to drive off a boat with a pointed bow. Higgins needs to modify the design. This is where Higgins meets a problem that stumps conventional designers. How do you make the front of a boat open up? A boat needs a bow to push through water. If you cut the bow off and put a ramp there, water will flood in. The boat will sink. Everyone knows this. It's basic naval architecture. You can't have a boat with a hole in the front. But Higgins doesn't think like everyone else. He looks at the British MLC design. It has a bow ramp that works. He studies how they did it. The British use a complex system of hinges, supports, and sealing mechanisms. It's over-engineered, expensive, slow to manufacture, but it proves the concept is possible. Higgins thinks he can do better. He starts sketching. He takes his Eureka design. He chops off the pointed bow. He adds a flat metal ramp that can be raised and lowered. When the ramp is raised, it forms the bow of the boat. It's watertight. When the ramp is lowered, it creates a bridge from the boat deck to the beach. Simple. The devil is in the details. How do you make the ramp strong enough to support a vehicle? How do you make the seals watertight? How do you make the mechanism reliable? Higgins works through dozens of iterations. He builds a prototype in his New Orleans workshop. It's crude. The ramp doesn't seal perfectly. Water leaks in. But it works well enough to test. Higgins loads the boat with sandbags to simulate weight. He runs it across Lake Pontchartrain. He beaches it on the shore. He lowers the ramp holds. He backs the boat off, tries again and again. The design is promising. The military hears about this and invites Higgins to demonstrate. He brings his prototype to Virginia in 1942. The military has set up a test range with simulated beach conditions. Higgins runs his boat onto the beach, lowers the ramp, drives a jeep off. The military observers are impressed but skeptical. Can it carry heavier vehicles? Can it handle rough seas? How many can you build? Higgins promises he can refine the design, make it stronger, build thousands of them. He just needs a contract. The military is desperate enough to gamble on Higgins. They give him a contract to build prototype landing craft. Higgins goes back to New Orleans and starts refining. He strengthens the ramp with steel reinforcements. He improves the hydraulics that raise and lower it. He redesigns the hull to carry more weight. He tests everything obsessively. He beaches boats hundreds of times, looking for weaknesses. When something breaks, he redesigns it stronger. The new design can carry a 36-foot-long vehicle weighing up to 5 tons. That's enough for a light tank or a fully loaded truck. The boat itself is 36 feet long. It has a shallow draft of just a few feet, allowing it to get very close to shore. It's powered by a diesel engine and can reach speeds of 12 knots. And crucially, it's built primarily from plywood. Steel is only used for the ramp, the engine, and key structural components. Everything else is wood. This is revolutionary. Plywood is cheap. It's available in massive quantities. America has huge forests and lumber industries. Plywood doesn't require specialized manufacturing. You don't need a shipyard to build these boats. You just need carpenters. Higgins realizes he can set up mass production in buildings that used to make furniture or railroad cars. He can hire workers with basic woodworking skills and train them in days. This isn't traditional shipbuilding. It's mass manufacturing applied to boats. The military designates Higgins' boat as the LCVP. Landing craft, vehicle, personnel. It becomes known universally as the Higgins boat. The first orders come in 1942. Hundreds of boats, then thousands. Higgins Industries expands rapidly. He takes over warehouses, converts old factories, builds new facilities. At peak production, his company employs over 20,000 workers. They're building boats around the clock, 7 days a week. Multiple shifts, the production process is optimized for speed. Plywood panels are cut to exact specifications. Assembly line workers put the whole together like a jigsaw puzzle. The pieces fit perfectly because they're all standardized. Glue and screws hold everything together. The whole hull can be assembled in hours. Then it goes to another station where the engine is installed. Another station adds the ramp mechanism. Another adds controls and navigation equipment. The whole process, from raw plywood to finished boat, takes about a week. But Higgins doesn't stop with the LCVP. The military asks for bigger landing craft that can carry tanks. Higgins designs the LCM landing craft, mechanized. It's 50 feet long and can carry a 30-ton Sherman tank. Same basic design as the LCVP, flat bottom, bow ramp, plywood construction, just bigger. Higgins Industries starts building those too. Then the military asks for even bigger craft, something that can carry multiple vehicles or 100 troops. Higgins designs the LCPL and the LCI, landing craft, personnel, large and landing craft, infantry. These are bigger still. Some are over 100 feet long. They're basically small ships, but they still use the same design principles. Flat bottom for shallow draft, bow, ramps for unloading, plywood and steel construction for rapid manufacturing. By 1943, Higgins Industries is the largest employer in Louisiana. The company is producing more than 700 boats per month. Not just for the US military. The British want them. The Canadians want them. Even the Soviets order some. Higgins boats are being used in every theater of the war. North Africa, Sicily, Italy, the Pacific Islands. Everywhere, the Allies conduct amphibious operations. Higgins boats are there. But the biggest test is yet to come. D-Day, the invasion of Normandy. June 6, 1944. This will be the largest amphibious assault in history. Over 150,000 troops landing on 5 beaches in a single day. Thousands of vehicles, mountains of supplies. The entire operation depends on landing craft, and most of those landing craft are Higgins boats. Planning for D-Day begins in 1943. The Allies know they need overwhelming force. They can't just land a few divisions and hope for the best. They need a massive invasion fleet. Thousands of ships, hundreds of thousands of men, and critically, thousands of landing craft to actually put those men on the beaches. Eisenhower, the supreme commander, reviews the plans. He sees the numbers. He knows that without landing craft, the invasion is impossible, and the majority of those landing craft will be Higgins boats. There are doubts. Some Navy officers still don't trust the design. Plywood boats, carrying tanks onto a hostile beach under fire. It sounds insane. What if the ramps jam? What if the boats capsize in rough seas? What if they get stuck on the beach? Any one of 1,000 things could go wrong. And if the landing craft fail, the entire invasion fails. Men will be trapped on ships offshore, while the Germans shoot them to pieces. But Eisenhower doesn't have a choice. There's no alternative. The Higgins boat is the best landing craft available. It's the only landing craft available in sufficient numbers. The invasion will use Higgins boats, or it won't happen at all. Eisenhower approves the plans. Thousands of Higgins boats are staged in England. Crews are trained. Mock invasions are practiced on English beaches. Everyone rehearses until they can do it in their sleep. June 6, 1944. Before dawn, the English Channel is crowded with ships, thousands of them. Battleships, cruisers, destroyers, transport ships carrying tens of thousands of troops, and hundreds of Higgins boats. Some are already loaded with soldiers. Some are being lowered from transport ships into the water. The seas are rough, higher waves than ideal. Some commanders want to postpone, but Eisenhower decides to go. The window for invasion is narrow. They can't wait for perfect weather. The Higgins boats form up into waves. First wave, second wave, third wave. Each wave has a specific objective. The first wave carries the assault troops who will secure the beachhead. The second wave brings reinforcements. The third wave brings heavy equipment. And on and on. Everything is timed precisely. Boats will hit the beach at intervals of minutes, disgorging men and vehicles in a continuous flow. At H hour, the first Higgins boats gun their engines and head for shore. The beaches are codenamed Utah, Omaha, Gold, Juneau, Sword. Each beach has different conditions, different German defenses, different challenges. But the Higgins boats have the same mission everywhere. Get to the beach, drop the ramp, unload, get out, return for more. On Omaha Beach, it's hell. German defenses are stronger than expected. Machine guns fire from concrete bunkers. Artillery shells explode in the surf. Some Higgins boats are hit before they reach shore. Some capsize in the rough seas. But most make it the ramp's drop. Soldiers pour out into the water. Some wade through waist-deep surf. Some are hit by bullets and go down. But they keep coming, wave after wave. The Higgins boats deliver thousands of men to the beach. On Utah Beach, it's less bloody, but still chaotic. The current has pushed the landing force off target. They've landed in the wrong spot. But the Higgins boats adapted. The beach here is actually less defended than the planned landing zone. The troops establish a beachhead quickly. The Higgins boats bring in more men, more vehicles. Tanks roll off the ramps onto the sand. They get stuck briefly, then power through. Trucks follow, jeeps, artillery pieces, everything the army needs to push inland. On the British and Canadian beaches, Gold, Juneau, and Sword, the Higgins boats mix with British landing craft. The British have their own designs, but they've also adopted many American Higgins boats. The results are similar. Heavy fighting, many casualties, but the boats keep coming. The sheer volume of men and material overwhelms the German defenders. Throughout D-Day, Higgins boats make trip after trip. Each boat completes multiple runs, deliver troops, go back to the ships. Load more troops, deliver them, go back. Load vehicles, deliver them. The boats are taking fire. Some are damaged, some are destroyed. But there are so many boats that losses don't stop the flow. For every boat that's knocked out, 3 more are already approaching the beach. By nightfall on June 6th, over 150,000 Allied troops are ashore in Normandy. Thousands of vehicles have been landed. Entire divisions are establishing defensive positions. The beachhead is secure. The invasion is a success. And it happened because Higgins boats did exactly what they were designed to do. They took soldiers and equipment from ships to beaches under the worst possible conditions. They did it quickly. They did it reliably. They did it in numbers large enough to overwhelm the defense. Eisenhower himself said after the war, "Andrew Higgins is the man who won the war for us. If Higgins had not designed and built those LCVPs, we never could have landed over an open beach. The whole strategy of the war would have been different." That's not hyperbole. Without the Higgins boat, D-Day doesn't happen. Without D-Day, the liberation of Europe is delayed by years. Maybe it doesn't happen at all. The course of history hinges on a plywood boat with a drop-down ramp designed by a stubborn boat builder from Louisiana. By the end of World War II, Higgins Industries had built over 20,000 landing craft of various types. 20,000, no other manufacturer came close. The Higgins boat became the standard Allied landing craft. It was used in every major amphibious operation from 1942 to 1945. North Africa, Sicily, Italy, Normandy, southern France, the Pacific Islands, Iwo Jima, Okinawa, everywhere. The design was so successful that it's still influential today. Modern landing craft use the same basic concept: flat bottom, bow ramp. The materials have changed. Modern craft use steel or aluminum instead of plywood. The engines are more powerful. The designs are more sophisticated. But the fundamental idea that Andrew Higgins pioneered remains unchanged. Higgins himself didn't get rich from his invention. He was paid for the boats he built, but he didn't own the design. The military controlled the patents. After the war, demand for landing craft collapsed. Higgins Industries tried to pivot to building civilian boats and other products, but it struggled. The company went bankrupt in the early 1950s. Higgins died in 1952, relatively obscure. Most Americans didn't know his name, but military historians know. Naval architects know. Anyone who studies amphibious warfare knows that Andrew Higgins solved a problem that seemed unsolvable. He did it not with advanced technology or huge budgets, but with simple, practical design thinking. Take the materials you have available. Wood. Make something cheap to build. Make something simple enough that anyone can operate it. Make something reliable. Don't over-engineer. Just solve the problem. There's a broader lesson here about innovation and problem solving. Sometimes the experts are wrong. Sometimes conventional wisdom gets in the way. Naval architects had generations of training, telling them boats needed pointed bows, that you can't have a hole in the front of a boat, that plywood isn't suitable for serious ships. All of that conventional wisdom would have prevented the Higgins boat from being designed. But Higgins wasn't constrained by conventional wisdom, because he wasn't trained in conventional naval architecture. He was a practical boat builder who solved problems based on what worked, not based on what textbooks said should work. He looked at the requirements: carry vehicles, beach on sand, unload quickly, be cheap to mass produce, and he designed the simplest possible solution that met those requirements. This pattern repeats throughout history. Outsiders solve problems that insiders can't, because outsiders aren't constrained by industry assumptions. They ask stupid questions that turn out to be smart questions. Why does a boat need a pointed bow? What if we just made it flat? Why do we need steel when plywood works? These questions make naval architects cringe. But they lead to solutions that win wars. The Higgins boat also demonstrates the power of mass production. One boat doesn't win a war. 20,000 boats win a war. Higgins understood this instinctively. He designed for manufacturability from the start. He made sure his boats could be built by semi-skilled workers with basic tools. He standardized every component. He turned boat building into an assembly line operation. This let him scale production to levels that traditional shipyards couldn't match. This approach to production was uniquely American. The US in World War II didn't win primarily through superior weapons or tactics. American tanks weren't as good as German tanks. American planes weren't always better than Japanese planes. But America built more, many more. The production capacity of American industry was overwhelming, and that capacity was enabled by people like Higgins, who understood mass manufacturing. The Higgins boat is a reminder that wars are won by logistics as much as by combat. Bullets and bombs matter, but you need to get those bullets and bombs to the battlefield. You need to get soldiers there. You need to keep them supplied. The unglamorous work of transportation and logistics determines who wins. The Higgins boat was pure logistics. It didn't shoot anyone. It didn't blow anything up. It just moved men and equipment from point A to point B. But that movement was the difference between victory and defeat. Today, you can see Higgins boats in museums. The National World War II Museum in New Orleans has several. The Smithsonian has one. Some have been restored to working condition and occasionally participate in reenactments or ceremonies. They look crude compared to modern landing craft. The plywood construction seems almost comical. But these simple boats changed the world. If you ever wonder whether one person can make a difference, remember Andrew Higgins, a boat builder with no formal training in naval architecture. A stubborn man who refused to accept that something was impossible. He designed a plywood boat with a drop-down front. And that boat allowed the Allies to invade Europe, defeat Nazi Germany, and win World War II. One man, one design. History changed forever. Drop a comment about other civilian inventors who changed military history and subscribe to see how D-Day innovations shaped modern warfare.